We're going to take a look at word problems using everybody's favorite point slope form. The ever clunky y minus y equals m times x minus x. You should have a blank copy of notes and a completed copy of notes available for you on the lesson plans. Make sure you read this scenario so you understand the scenario as we go through the sheet, or the sheet is worthless. So go ahead and pause the video and read and absorb. And these are going to be a little bit unusual. As I read through this problem, I'm going to notice that there's two parts that can be turned into ordered pairs. Company sells 40 products and earns a $520 profit, 40 comma 520, and the same thing over here, 75 products, a profit of 1,220. So by reading through here, I can go ahead and make two ordered pairs. So this next part looks like a lot of writing, probably because it is, but once I have my two ordered pairs, 40 comma 520 and 75 1,220, I can go ahead and make this equation. Remember, this equation needs a slope and it needs a point. So I can use either one of these points I want, but I do need a slope. So I have to do a version of y minus y over x minus x, and that's what you see happening over here. We end up with a slope of 20. So if my slope is 20, I get to choose any of these 2 points. For my work, I chose that point right there, 40 comma 520. So that point and that slope went in to make that equation. So that's the equation that represents this scenario. That's a pretty weird transition. English that you can understand, some very weird looking equation. Okay, now that you're done with that first scenario, we have a brand new scenario right here. And now it might be a little bit easier for you to read through there and come up with two ordered pairs. So see if you can pause the video, read this scenario, and come up with two ordered pairs just like I did in this previous problem up here. Okay, so as I went through here, I saw that on day 3, we had 42 pounds in the compost pile. That's an ordered pair. On day 10, we had 21 pounds in the compost pile. That's another ordered pair. So it's kind of weird and unusual. You probably haven't done this much before. Reading through a scenario, you can come up with two ordered pairs to represent the scenario. So once you have those two ordered pairs, you can go ahead and get that clunky equation. You need a slope and any point. So I'm going to go down here and do my slope. This is a y minus y over an x minus x. I get my slope. I get to use either one of these 2 points, so I happen to use the point 10 comma 21, but someone else could have used the other point, the 3 comma 42. So then this is my equation using my 10 comma 21 point. If somebody used 3 comma 42, they would have this equation over here. And by the way, either of these equations, if I solve for y to turn it into y equals mx plus b, I'm going to arrive at the same answer. So my equation, once I solve for y, ends up being the same as the other equation once I solve for y. So they look different in the beginning, and that's totally fine. People can go use whatever point they want. But if we convert to y equals mx plus b, totally identical. It's probably a lot easier to work with y equals mx plus b. So we're going to make a graph of this scenario, and what you can do is you can take your slope-intercept form and just make a little table for yourself. I just happen to choose 0, 5, 12, and 17, but there's nothing magical about those numbers. However, there is something magical about this spot and this spot. This has a y value of 0, so it must be an x-intercept. This has an x value of 0, so it must be a y-intercept. Those are good numbers or points to put onto your graph. 0 comma 51, 17 comma 0. Once I've plotted my two intercepts, I can just connect them and I have my graph. As usual, the x and the y-intercept represent something. So my y-intercept of 0, 51, that's the coordinates. That's just telling me on day 0, we haven't really started the scenario yet, the compost pile weighs 51 pounds. It starts out at a weight of 51 pounds. By the way, this intercept down here says 17, 0. And that's telling me after 17 days, the compost pile has composed down to a weight of 0. Now we happen to have the intercept from our t-chart, but if we didn't, and we had to actually find that spot, we would just use this idea. Every x-intercept in the entire world has a y value of 0. So we would have plugged in a 0 for y in our equation. Once I do that, I solve for x and I get my 17. The final two questions in this scenario, we're talking about the range in this case, which remember the range is your y values. So if I'm thinking about the t-chart up above, I'm thinking about that. If I'm looking at my graph, I'm thinking about the y, every possible y value as I go along. So the biggest y value I can ever get to is 51. The smallest y value I can ever get to is 0, which makes sense because a compost pile can't ever weigh less than 0. It can't weigh more than 51 because that was the beginning weight. So it's unreasonable to have a negative value in the range because the compost pile can't have a negative weight. It would be unreasonable to have a value of, say, 100 in the range because the pile started out at 51 pounds and was just losing weight after that. So these are pretty unusual. The key to a problem like this is reading through the scenario and finding 2 points within the scenario. 2 points within the scenario. Once you have your 2 points, you can compute a slope. Once you have a point and a slope, you can get into point-slope form. This point-slope form is a little clunky and not very usable, so most of the time people would prefer to solve for y and put it in slope-intercept form, which is very friendly and usable.